Those are just oh, I have to start. Got it. And I have to actually, I will record on this computer. Yes. Yes. Okay. So the first thing is this gradient divergence curl business. Those are basically calculations. And the other thing is Taylor's theorem, which is an absolute pain, so I will not do that here. And maxima and minima, which is very important, which we must learn. And in order to point out the relevance of this maxima minima business, I will send you the paper about the structure of the DNA and how it, when it is replicated, it does so under very strict constraints. And the constraints are helicoidal surfaces. Okay, so let me do a few calculations. And since all of this is worked out in the notes, did you manage to get the notes or no?
I haven't received anything.
No, did you manage to, I mean, are you allowed to have the, do you have access to the stuff that is on?
I do have access to a count report, but it's one from last year.
You still have the same notes, you haven't changed your notes.
I don't think so. He is an observer. He is listed as an observer. Yeah, just send them to him. I mean, yeah.
My question was, is you haven't updated or changed your notes?
I don't think so.
So, because you take it during like the.
But I spotted a mistake today before Maxim caught it. So Maxim must not have read it. So I will not say what it is. I will let it remain. Okay. So three things. Gradient, no, four things: gradient, divergence, curl, Laplacian, five things actually, and directional derivative. So the gradient is the rate of fastest increase of a function. Okay. So in order to understand this, suppose I have, no, before I do that, I have to say one more thing. Going back to these t-shirts and pants, etc., from last time, suppose I had, we talked about an object that looked like this, right? Yeah. So if I call the shaded part D, in that case, the boundary of D is represented in this manner. Is defined to be the boundary of D. Boundary. It doesn't matter.
How are we looking?
We are not looking at the pants at all. The pants are made of rubber and it is stretchable and very strong and durable. So the outer circle is the waist, and the legs have been collapsed into. Of course, it's a plane.
Okay.
It's a disc with two holes. That's all. Wow, if everyone knows about such things.
No, well, like a disc has that's like it stretches all the way.
Oh, that's I have to
the opposite direction. So instead of us making it, he's turning that. You know, like. So.
Yeah. Yes, I mean, it will not be very difficult actually. If you have some elastic material, and if it could be tied at the waist and tied at the ankles, it's very easy to make. Now, I intended to get some models for you, but I forgot. I mean, I was thinking last night about what to bring to really make it completely crazy.
Well, I was going to actually fire the time to fire
this weekend, I was gonna come and try cylinder.
Yes.
So I found.
I will write that up tonight. That is what I want to do. I changed my mind and I will make the cylinders elliptic. That will sort of,
Okay, changes it.
not much.
Yeah, it's just-
Yeah, so elliptic cylinders, and that would make the answers different for, but you should work together on this problem. And I will add that at the end of the problem set and I will upload.
And has 40
Yes,
and has
that
like
makes it
40
very
points.
nice. And that alone will be worth 40 points. The other problem is, I think, a bit too difficult for people. So
we don't have exams, but we have
extra, yeah. But we will have solution for the exam. Choose a color of beard.
our beer.
Yes.
Yeah, rainbow beard. My beard.
It would have to be a real stretch of the word rainbow to match it.
Yeah, mine's multi. It has every single hair. It's great. It's so great. You can go multi-beard or.
Why is it shading?
It's like this, because I have to. shave
That's his way of protest.
There's blonde and orange and yellow, red and black hairs. and brown.
Now he has chosen purple, and orange and yellow have been taken. So you choose a color.
Or white beard.
Because that's what is traditionally the name of the person who makes up the solutions. So posterity will suffer from orange, yellow, and purple beards, and you choose one.
Navy.
Navy, okay, navy beard. Blue beard actually was a pirate. So navy is not really a color. Navy blue is a color. But so you want a navy blue beard. Blue beard was a famous pirate. Okay. So now, yes.
Oh, fine.
Okay.
It's gonna be my new game.
Okay. Let's see. But okay, the point that I want to make, which we should understand, is the following: that this disk with two holes, the boundary needs to be given an orientation. That means a sense of direction. So the positive orientation is always one in which, if you walk along the boundary, which you can't see, then the boundary will be to your left. So I'm thinking of someone walking along the boundary. This is the person. Okay, so as he walks along the boundary, the surface would be to your left. So which means this we shall call C1. But if you do that on the inner circle, for the boundary to be on your left, for the disk to be on your left, you have to go in the opposite sense. Do you see that? You have to go this way. So C2, C3. So del D is equal to C1 union C2 union C3. Okay? And so there is another notion that I need to talk to you about, that is called a capping surface. So what is a capping surface? Suppose I give you some sort of a curve, okay, which may or may not lie in the plane. Then any surface which has that as the boundary is called a capping surface. That has the boundary. Yeah. So for instance, if I have a disk in the plane, not a disk in the plane, a circle in the plane, then I can have a disk of which it is a boundary, but it can also be a cap like this. Do you understand? Both of these have the same boundary, yes. Yeah. One is both are two-dimensional objects, so there are two folds, but they're distinct two folds. One has curvature, the other doesn't have curvature. Okay? You could also think of something like this. What? No, the surface is two-dimensional. It is
Sure.
embedded in three-dimensional space.
Oh,
It is not three-dimensional. Do you understand what I'm saying? So if I make a yes, just a moment. This I should be able to show. Oh, I never performed this experiment to prove to you that you really do not understand the distinction between one and two.
oh.
One and what? Cats, cows, unidentified flying objects.
No, okay, it's actually supposed to be. No, it's a different blue letter.
That's half a cone, so let's see. I can have a circle over here, so this is the capping surface, but the disk is also a capping surface. Okay.
Okay, so, the disk is a circle that's still, right?
Hmm?
This would be a circle that is still, right?
Yes, the boundary of the disk is the circle, and the disk itself is called a capping surface for this circle, because you will have to choose capping surfaces later. Incidentally, there's a theorem in physics which says that if you have a soap film, and if you you have to have a, you've seen children play these games. You have a wire and then dip it into soap water. When it comes out, there's a film, but that film actually is a minimal surface, which means its area is, of all the possible surfaces, the surface that the film that forms has the least area. So what you can do is to take two sort of wire circles with handles, and you dip it into soap, you hold them together and you dip it into soap solution, you pull it out and pull them apart. There are two minimal surfaces actually. One will look like this, and the other is two disks. And you can see both if you perform this experiment. So you take two of those children's sort of wires with a handle, hold them together, dip it into soap solution, take it out and then pull them apart. Then you will see initially a cylinder forming, and then it will break and there will be two. So both are minimal surfaces. Okay. So the idea of this extrema is extremely important, because laws of motion in physics arise from the minimization of something called the action function. So all the laws in physics can be derived in that manner. Maxwell's equations, Newton's laws, everything. And what was I going to say? No, this doesn't belong here. So you understand this, right?
Yeah.
Okay. So now the quick calculation. So gradient, I told you, is something that takes as an input a scalar field and gives out a vector field. So we can do this in something, an example is worked out, and this is very simple. So suppose I take the scalar field. What scalar field shall we take? XY. So P is, I'm getting a bit tired of writing the ones and twos and so on, subscripts. So I'm going to write XY. So rather than del 1 and del 2, we'll have del X, del Y. Okay. Going to XY from R2 to R2 cross R. This cross R has been left out in the notes. So that is one change I should make. So that means this value xy is at the point xy, and we want to carry the information that it is at the point xy. Okay, so gradient of phi is equal to okay, this is the operator, upside down triangle to represent the gradient, and this would be del x of phi, sorry. Del y of phi is equal to del x xy del y xy is equal to y x. Okay, but I gave you a general, there's a general formula in the notes for what happens in n dimension. And this is the direction of fastest increase. Okay, at the particular point. So there's a little bit of visualization that I should give you. Suppose I have on some surface two bumps like this. Okay, and you want to depict it. I didn't call the surface anything. If bumps, I said there are two bumps. Okay, so this one is the steeper one, right? So if I take the what I call level curves. Level curves means the value of the height is constant, and draw them. These will be circles. So these, let's say these are circles, right? So I would get corresponding to the first one, concentric circles which are closely packed. Whereas this one will give you concentric circles that are widely spaced. And then we shall have something like this. No, this is, I am slicing them by parallel, slicing them with planes parallel to the base. Okay, so the radii of the surfaces will be closer for this one and further apart from this one. And this basically means that, actually, I mean, this is very schematic, it's not very accurate, that it's steeper here and it is less steep here. That means the circles will be spread out further. Here they will be close knit together. Okay. What kind of map? Strain map. No, there are maps like this, of course. A terrain map, T-E-R-R-A-I-N. Yes, exactly. Yeah. In other words, if you have uneven terrain, in that case, this gives you an idea of what the heights are going to be like, or how steep it is going to be to get from one point to another. Okay.
This part is able to easily visualize if you watch the video.
Yeah, the video is very good. Yeah. Topological what? Terrain map. Topological, well. Yeah.
That was the map.
Okay. But please watch the video. Please watch the video.
The one that was posted into the Discord under John.
The one called Kurotiansky, right? Khutoriansky. Yes, Eugene Khutoriansky.
Okay.
Yeah, those videos are very good, very, very good.
The physics video, but divergence and curl.
Yes, yeah, that's the one.
Yeah, it's posted.
Yeah. So now, a calculation of divergence. So divergence is, it takes a vector field and gives you a scalar field. Okay, divergence in 2 dimensions. So divergence, I say in the notes that this thing should really be written as gradient phi is a vector field that is xy going to xy comma yx from R2 to R2 cross R2. But this last step is not needed for the exam. You just stop after calculating the vector. We understand that it is attached to a particular point. Okay. So suppose I want to take the divergence of that. Let's call this define alpha to be del phi in the above. Okay. So divergence of alpha is equal to del dot del phi, which is equal to del x del y. This is a sort of, it's a dot product, but it's not really a dot product. The dot product is, I'm writing the dot product, but these are not vectors. So, but it means that you have to operate with it, which is equal to 0, 0. So if there's this is a general theorem that if the divergence of the gradient of something is always equal to 0. Always. This is called a conservative field. A conservative field has no sources. A conservative field is one in which if you take some object from one point to another, the work is independent of the path. This is something that, who are taking electricity and magnetism? He's not here today. Yeah.
I finished that course. Electricity and magnets.
Oh, I'm seeing it right now.
240, yes. So he's in your class.
Yeah, well, no, he's saying.
No, that this, his name is Joseph Fuller.
The lab is in person, but the class is in the sure.
Is the person who's in the class also in that class?
Oh, you don't know him? Oh, you haven't? No, but you don't go to the labs? You haven't seen him in your lab?
But I just didn't want to wake up and.
Okay, so
Okay.
they're living labs.
Yeah, so there's no need, yeah, you may not be in the same lab. Anyway, so but
You were saying that the divergence of a gradient.
it always, yeah. The divergence of a gradient is always. So, so basically, divergence measures the source. And so this is called a conservative field, which means the work will be independent of the path. In a non-conservative field, work will be dependent on the path that you choose. So it is in your interest to find the path that will minimize the work. So nature is not wasteful, but it always minimizes effort. And so this is a very profound principle. And the papers that I will send you on the structure of the DNA, partly to kill the view that biology does not require mathematics. We are just beginning to understand these things. So protein folding is something which is best discussed in 163 because it is a kind of spatial commutatorics. Whereas what I saw yesterday, they're very, very interesting papers on how the symmetries affect the shape of the DNA. So the molecules basically, very roughly speaking, are certain solutions to a certain kind of differential equation called Schrödinger's equation. And what the chemists do is to, at the equation, the unknown is a probability density. So the probability density will have certain maximum. And what the chemists have are models of the maximum value of the probability density. That's what those models are. So we have a discrete aspect of the problem and a continuous aspect of the problem. So you have to pack these molecules which are attached to each other along sticks, basically, because these are the covalent bonds which are strong. So you have to pack them in such a way that the energy is minimized. So this is what gives you the shape. So when a virus attaches to a cell, it uses something similar. Then I saw another paper on the recognition of DNA, because we have immune systems that do exactly that. And these are all very interesting questions. So rather than working for Lockheed on more balloon busting objects, you should look into things like biology. It doesn't make any difference.
So
Yeah.
It doesn't matter if you set up the columns for it or you actually put the word on the board.
But
Of the word. You do that for you.
Yeah. You're
Paying their money, basically.
that's already a problem. This is the whole story of Faust.
Either okay with it or you're not. You can't be like, oh, well, not really. Not really okay with it.
But let's proceed. So we did gradient and divergence. And what do we do now? Curl. Curl is I will do it only in 3 dimensions because it has many generalizations in higher dimensions, but they are they capture information about various kinds of rotation, which we will not bother to talk about. I will not bother to talk about. But let's take, okay, I need a vector field. So beta X, Y, Z, this is going to be in 3 dimensions. 2 X, Y, Z, comma, what shall we make it? Okay, YX. R3 to R3 cross R3. Then the curl of beta is this cross beta, which is equal to, I have no recollection as to what notation I used in the notes. This should be the determinant, but I put it within quotes. After the debt. Okay. No, then what is in the top row? IJK or EXEY is easy? In the notes?
C notes. Or
Yeah, 1 C notes. E.
So for the curl, right?
Yeah. Row.
First curl is
So I will make it EXEY EZ. EY EZ. and then del x, del y, del z, and what did you say it was? Yxz. Yxz. So this will be equal to, now, of course, you calculate this. The top one is Ex, so it would be del yz minus del z, del zx. The next one, Ey, it's backwards, so it will be minus, if I make it minus del xz minus del z y. And the last one, Ez, is del xx minus del yy. So I'm very happy that it is 0 minus 0 minus 0 minus 0, 1 minus 1, which is equal to 0, 0, 0. Okay, so which means that this actually does not show any rotation. But I just showed you how to calculate. So divergence measures the strength of sources and sinks of the field. Gradient measures the fastest increase. And what's the other thing? Curl measures the strength of rotation. Okay? No, your exam will not be like this. So, but you chose the problem. Long ago, I used to teach exclusively arithmetic in the fall and algebra in the spring. So my students, it was in a room at CCP, which looked like an L. So so the door was here. It still exists, I think. And the room was shaped like this. And the blackboard, I think, is here. So the people over there couldn't see. So, so I complained and complained, but the number of students was sufficiently small, so they were all sort of assembled in this area. The people could see, but they were complaining and complaining bitterly that apparently I made the exams too difficult. My exams did not contain any numbers other than 0, 1, and 2. And plus 1 and minus. I mean, of course, with both signs. Occasionally, very occasionally, pi and e. So I said, okay, you think my exams are difficult. Okay, so you make the exams. So I asked each student to make up an exam. So they sat 1, 2, 3, 4, etc. up to n. So I just had 1 pass the exam to 2, 2 pass the exam to 3, etc. and n's exam came to 1, sort of like cyclic ordering. And then they had to do it. So then they, well,
Was the result of this? So
the result was actually a war, which I almost had to call security to stop. Because they blamed their neighbors for giving them hard problems. And so I said, I didn't have anything. So who should make the exams, you or me? So there was unanimous agreement that I should make the exams. So.
Wait, let me get this straight. They all have the opportunity to make an exam.
Yes.
That you would accept for like 4 points, right?
Oh, yes, but if one can't take one's own exam,
Yeah,
one has to take one's neighbor's exam.
So the game theory here would be everyone should make the simplest acceptable exam for everyone else.
They couldn't, there were no restrictions whatsoever. They could have they could have made any exam of their choice.
Basically, this based on the history of like, we did it with separate.
Yes, it was. No, not any subject on what I was teaching, which was basically arithmetic, addition, subtraction, multiplication, division. But I don't know why, well, they made the exam. So they put numbers like 123.789. So, and then there was no complaint after that. So it was, but they understood that my exams were far easier than what they were dreaming of. So anyway, I saw one student from that time after 20 years on Walnut. And she said that, oh, I still use those notes. I was astonished. And then she came and took pre-calculus with me. Yeah. 20 years later. Yes, because she went somewhere after this.
Some programs only require you to take pre-calculus.
Yeah, I don't know. She moved somewhere else, but anyway, but
Experiment.
it was a successful experiment. Although I would have had to call security because they really ran at each other's throats that you deliberately put these horrible numbers in here to cause me trouble.
You see students as experiments.
Hmm?
You see students as experiments.
Not the students perform the experiment on each other.
Okay.
In this case, the students can't. How can a student be an experiment?
You were just an observer.
Yeah, I had the students participate in an experiment and I was just the observer, but I had a motive. The motive was to establish that my exams were more reasonable than exams that they made up. And they agreed, not just with no dissent whatsoever. It was unanimous agreement. So, okay. Okay, so now, you see, if someone claims in this class or in this sort of thing that my exam was more difficult, then I have an answer. The answer is that I didn't choose your gene. And number two, there's a strict definition of equivalence according to which the problems are the same. I mean, equivalent. They are instances of a particular function, effectively. So if someone got an easy 3A part 1, they may get a horrible 2B part 3.
Yeah, but I think the more zeros you have in your J number, the more general, easier it is your exam. Yeah,
No,
like from discrete math 1.
no, discrete math 1 also has some problems with zeros.
Yeah.
I remember.
Many exams.
I remember then I took everyone who had more than 2 zeros in their game number was having a much harder time.
Yeah, I remember 163. There was some point in time where
You had 3 zeros.
Yeah.
Yeah, of course, because your GMD number is 3 zeros. But okay, but sometimes the zeros have to be changed into ones in linear algebra. But let's see. Let me calculate. I have calculated. We had gradient divergence and curl. The directional derivative I will not calculate, but it's defined in the notes. It just takes the dot product of the gradient with some vector. So it shows the rate of increase in a particular direction. That's what it gives you. Okay. And Laplacian is very easy. So Laplacian of the first one. Laplacian you can calculate of a scalar or a vector field. So I will do it for a scalar field. So Laplacian of phi from the beginning, right? So that's it was xy, wasn't it? The scalar field. Okay, so that's equal to del x of y plus del y of xy, sorry, of xy is equal to del x of y plus del y of x is equal to 0 plus 0 is equal to 0. Okay. 0 is the best number in the world, so I'm very happy. So,
Why is zero less than 34?
yes, it is a additive neutral, multiplicative annihilator. It comes with no baggage whatsoever.
Somebody can't divide.
You can't divide anything by it, yes.
I give that good.
Oh, that's very good. Division is always bad.
It is almost the perfect thing.
Yeah. Unification is always good.
So everything divided by zero is the same.
Yeah, but let's see how many of you know what is the value of 0 to the power 0. You are not allowed.
That's why I raised my hand to this.
0 to the power 0.
One.
1. Okay, and how many of you can prove that?
Like, can't prove it, but I've seen how it's done, so only through it down.
Then you know nothing. Yeah. That's almost as bad as believing New York Times.
I don't know with the proof that it passed.
Well, 0, you always have to think of a combinatorial proof. 0 to the 0 is a number. What does it count? It counts the number of functions from the empty set into the empty set. And there is exactly one such function. Or it counts what is 2 to the 3. 2 to the 3 is the number of 3-letter words in an alphabet consisting of 2 letters. So if you have A and B and you have to make 3-letter words, repetition is allowed, order does not matter. So you can have 2 choices here, 2 choices here, 2 choices here. 2 times 2 times 2 is 2 to the 3rd. So if you have 0 slots and 0 letters, you can still make the empty word. Yeah, no, empty word, empty list,
Empty word.
not empty set, empty list. Okay.
My other question is, I know, precedence.
It's required for you to be able to use any powers due to multiplication of powers means the addition. So you had that, you had to have 1 0 to anything would be the 1, so that'd be another method to complete the proof besides just saying.
That's for consistency, yes. But yeah.
Yeah, so could you use consistency as a proof?
No, but it shows that the fundamental definition agrees. Yeah. With what is consistent.
I think we should take a break.
Okay, we'll take a break. So stop recording. I will also stop recording. Pause. We are going to take a break. That's you. Yeah. Okay. So
It's like when we have a set number of things, like expect every single.
yeah. So yes, that I allowed in very particular problems. So that you scan from left to right and observe if the things are in the proper places. You could write it up, but I use the code by inspection to mean a certain specific sequence of acts. Okay. So now, but then they say the second derivative test, which actually will fail in the case of the simplest function. So suppose I have y is equal to phi of x is equal to x to the 4th, where the graph looks like this. So dy dx is equal to 0. From that we conclude 4x cubed is equal to 0, which means x is equal to 0. So 0 is a critical point of the function phi. But now d2y dx2 is equal to 12x squared. And d2y dx2 as x is equal to 0 is equal to 0. Therefore, the second derivative test fails. Clearly, it is a minimum. But the second derivative test, which these fact books talk about, is useless in this case, in such a simple situation. d3y dx3 is equal to 24x, and d3y dx3 at x is equal to 0 is also equal to 0. d4y dx4 is equal to 24, which is bigger than 0. And so what you need to say is that the order of the, if the first derivative at that point, which is non-zero, has an even order, and if the value is bigger than 0, then that is a minimum. If the first derivative that is non-zero at that point has even order and the value is less than 0, that is a maximum. And if the first derivative at which a non-zero value is reached at the point is of odd order, then that is an inflection point. And these are exactly 3 possibilities. Okay? In many dimensions, the possibilities become much more complicated. This is a local maximum. This is a local minimum. But then you also can have things like the horse's saddle, which is a minimum in one direction and maximum in the other. You see, like the back of a horse. Okay? But these are all isolated extrema. You could also have this sort of situation. This is a bowl with a bump at the bottom. But you see, this is a local maximum. And the around is a local minimum. So if you can balance a ball at this point, but if you give it a slight push, it will actually slide down. So this is called an unstable minimum, maximum. But on the other hand, if you have a ball over here, if you give it a slight push, it will remain there. So this is a stable minimum. But the stable minimum is not an isolated one because all around it's in a circle. So it's of dimension 1. It is not of dimension 0. It will go just run along the thing. It will just go around. Or you can oscillate a little bit and come back to the same point.
Okay.
So in other words, equilibria which are stable and unstable can be very important in applications to physics. So for instance, you want to devise physical objects such that if perturbed slightly, it should come back to the equilibrium position, not sort of, the perturbation should not increase. That would make the thing very dangerous. Suppose like the blade of a fan, like a propeller of an airplane, if it moves slightly because of the wind out of the plane, that oscillation should be damped. Because otherwise, if it becomes very large, the plane would crash. So we have to design things in such a way that they are stable. The human body is very stable. We last about 100 years, roughly, without too much problems. Gradually, things become a little worse for wear, but still more or less. Okay, so now we will study these extrema. So these are called free problems. That means there are no constraints. Okay, and there's problems that are worked out in complete detail is the classification of the extrema which becomes difficult. So there are 3 steps basically. You would have to set the derivative equal to 0, and that gives you the critical points. Then you have to test each point separately. In order to test the points, you have to look at the Hessian, and the Hessian is actually the second derivative. And the Hessian actually is a symmetric matrix, and it has the second derivatives along the diagonal, and it is the cross derivatives along the of diagram. So I'm not going to bother writing the definition down. The example that I've worked out is phi of xy is equal to xy times e to the minus xy. But it is written in terms of x1 and x2, not x and y. Okay. Can you check on your computer if they will draw a graph of this function in 3 dimensions or on your calculator? Look up graph on the internet. Did anyone try?
Oh, 3 dimensions.
Yeah, that's, I was.
Yes, z is equal to xy. Let me see. Let me see, I have to go and look. Yeah, you see there are 2 maxima and 2 and the saddle one. Okay.
Wait, right?
Function xy times e to the minus x1, not minus x1.
Right.
So change the function.
Oh,
So it's going to be here.
Yeah, exactly.
It's a term, you know, that's
Yeah.
any lines and it fills in the leaves.
just take it every time you want to.
Did anyone get it?
What, yeah.
Oh, yeah, it's perfect. Here you go.
What program was this? Geo Jabra. It's Jabra. Yeah, it's it.
I didn't have a good DB word, so.
Zandura.
Okay.
Oh, that's not.
No, it isn't.
No one. Anyway, it's worked out. Actually, you should look. I cannot remember now if it. Let me see. Yes, there's a saddle point in the middle. And there are ridges. So one can't tell much about maximum and minimum.
Oh, we can move it.
Yeah, it's still not very. Yeah, these will have ridges. Okay. But can you check what is the problem that I worked out in the. Yeah. In the notes. E to the xy times e to the minus x squared minus y squared. Or is the xy times e to the minus xy?
In the extreme,
Yeah, section, yes. I worked out one problem. While I was in quarantine in Mumbai.
where,
Mumbai. Yeah. In India.
wait, they still quarantine in December.
Hmm?
This
No, this was from long ago. Before that, the students didn't have notes. I mean, because I never wrote, I just did whatever came to my mind on the board.
Is it in the beginning or?
Towards the middle. Yeah. x1 times x2 e to the power minus x1 x2 or minus x1 squared minus x2 squared.
That was it. Was X1 to 0x?
No. The function for which I'm finding the find and classify the extrema would be the search for find and classify the extrema.
I see it finally classified the critical point.
Of yes, of what?
P, is defined to be, or is trying to be,
x1, x2 times.
yeah, x1, x2 times e to the negative x1 squared plus x2 squared.
Okay, so that's the one that you actually, that's similar to what he did, but you should plot the, so not this function, but phi of xy is equal to the one in the note says x1, x2 times x1, x, sorry, let me erase this. Phi of x1, x2 is equal to x1, x2 times e to the minus x1 squared minus x2 squared, right? That's, yeah, that's a good one. So that I have classified all the, so you should look at the problem in detail. Your problem is going to be much more painful, but we don't want to calculate the Hessian. That is the most important point. The Hessian, you have to look at its sign at the different places. If you just want the sign, it breaks into a bunch of pieces and you want to know whether it is, you are multiplying positive numbers or some combination of positives and negatives. So things become equivalent if they have the same sign, then the analysis will be the same. So I want you to use the notion of an equivalence class to reduce work. I showed tic-tac-toe to you, right? Understanding which moves are equivalent, reduce the problem from 9 cases to 3 cases. So that's exactly what you do over here. So if you have 27 different things to look at, it may actually, based on a good analysis, be reduced enormously. Okay? Okay. Then next thing that I have to talk about is constrained extrema. Constrained extrema, so you have a function and you have a constraint. So it is good to look at an example. The one that I constrained extrema. So suppose you have an experiment of this kind. These are the axes. This is a wire. And on the wire, there's a bead. And the bead is tied to the axis with elastic strings. And you're moving the bead along that line. So obviously the bead could be here, or the bead could be in the middle, or the bead could be over there. So I want to find the extreme values of the area enclosed by the two strings. And this is technically find the extrema of the function P of xy is equal to xy subject to the constraint x plus y minus 2 is equal to 0. This straight line has the equation x plus y minus 2 is equal to 0. Okay? So this is an example of a constrained problem. The papers that I'm going to send you are trying to understand the nature of the replication process of molecules, of the DNA in particular, in terms of optimization problems. So the constraint is in the form of a helicoid, and what is being maximized is, what is being minimized is energy. And what is the process? Packing these molecules. But there's a discrete element because the DNA consists of 4-letter words strung on a, so the helix and the helicoid come up because they minimize certain energy functions. So these are very, 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 very interesting problems. Actually. So, so those of you who have friends in the biology department should prevail upon them to take more mathematics, and also the computer science people to take 271, because 271 gives you the possibility of working in vision, which is extremely important to simulate vision. To simulate vision is a different thing from understanding what vision, how human vision actually works. I think that is a far more interesting question. The whole point of artificial intelligence is to make machines that behave in some respects as human beings do. That does not give us any understanding whatsoever of how the brain functions. And if it replaces human beings, then we are in for a lot of trouble. Yeah, because but somehow that I consider to be a cult of death. And it is extremely, what shall I say, menacing in its proportions in the US at the moment. So that people are giving up on actually living. So I will give you an example. I remember the numbers that I call, but now, of course, since cell phones came into being, people actually look up their names and then click. With the result, what is happening? Downward slide towards cabbage. Yeah, that will go. Plus the number.
Personally, remember the 7.
Yeah.
Now it can-
Yeah.
and then
Yeah. If you treat your brain as an expendable item, then you deserve to become a cabbage. And then you will turn into sauerkraut. Not yet. Well, but everything in Walmart is made in China. Once you start shooting Chinese balloons, you might get an actual cabbage rather than a brain.
What is the line of like having big?
It is not if it is turning me into a cabbage, yes, it is making my life very easy at some point.
Well, I mean, everything we have calculators, like.
Listen, we're-
If you don't understand how to calculate, and then if people press buttons on a calculator and tell you rubbish, you will not be able to distinguish.
Well, yeah, but like, I mean, people can't remember numbers. Doesn't.
They cannot. I'm not a person in that case.
I mean.
What are you claiming?
What I'm trying to say, okay.
Your argument makes no sense at all. You just did. You made a claim. People can't remember numbers. Yes. Okay. Okay. Some people remember certain sets from.
People can remember numbers.
Yes.
Okay, so they don't have to remember numbers, but they also use technology to like have the number 6.
They are using technology to turn into cabbages because the brain functions in a certain way if you have to remember, and the synapses actually work, and the neurons have currents flowing along them. No, running is very good.
What is the difference?
Riding or running? Writing?
Yes, right. Writing is good. Why is writing better than the oral methods of shape? Why is writing down a story better than telling a story? And then having to remember it.
No, there's nothing wrong about that at all. So writing simply is a more secure method of preserving the information. That's all. It doesn't mean that you should stop memorizing things.
But it's more secure method of memorizing.
No, of preserving. Yes.
The number both say that. So
No, I am just saying that just if you do not exercise, the heart gradually becomes weaker and weaker, and there will be problems with blood pressure. In exactly the same way, the brain will atrophy. And soon one will be not distinguishable from a cabbage, and at some point from sauerkraut. These are not worthy goals.
Memorization of numbers.
Not memorization, but exercising the faculty of memory, of which memorization is an example. So the brain has certain features. You can try to, the brain is not a muscle.
It's like a muscle. It's like a muscle.
It is not like a muscle either. It's a much more complicated object. But if it is not exercised, in that case, it fails to function. So memory is a feature of the human brain, which should be cultivated. So all features of the brain should be cultivated. And abnormal dependence on technology, as one finds here, is harmful to the human organism. That is what I'm trying to say. You do not go and drink poison if someone says it is very good.
So a bunch of rich people don't give their kids any technology until they turn 12. They don't download those greens or tablets. So they actually take excellent adolescents to make sure they have the of actual tactile sense.
Well, I find it very stupid that like I see like children like in career and having a giant iPad in front of them. Like that's just generally too much in my opinion.
Well, we'll see. Let me come back to that. So this is, so I mean, it is, the answer is obvious in this case, because if the point is here, then the y coordinate is negative, the x coordinate is positive. So that x times y is negative. Similarly, if the point is here, the x coordinate is negative and the y coordinate is positive. So if you leave the first quadrant, the value becomes negative. The value obviously becomes 0 at these 2 points. And then it increases, and somewhere along the line in the first quadrant, it should reach a maximum. This we know from the geometry. We will prove next time what is the case. We can ask a similar problem where I can consider there's a point like this, and I can consider the cube formed by that point which is moving along a plane. There's a plane and it is moving, the point is moving on the plane, and then I drop perpendiculars on the and draw a cube with a vertex at that point. The question is, what are the extremes? I can make much more complicated problems. I mean, I could produce, let's say, this is a hyperbola, and I take a point here and take a point there, and I join the two. And this point has to move along this curve, this point has to move along that curve. Find the maxima, and find the extrema of this length. Okay, clear? So there's a very famous problem known as Dido's problem, who was given I think it was in Carthage, that she was given the option of getting as much land as she could enclose, and they gave her a hide, the skin of a donkey, I think. I don't remember the story exactly. So what is the largest, but forget about that. The point is, suppose you get a string. What is the maximum area that you can enclose with a string? It was proved not very long ago that the maximum area that you can enclose is enclosed by a circle. Okay, so that's a much more complicated problem than the one that we are facing. But when I send you the papers, you will see that things of that kind are actually being worked out in our bodies automatically using algorithms that, if you really like computer science, you should try to understand. Okay. And then there's Taylor's theorem. Taylor's theorem is so boring that I don't want to talk about it. But I have done an example in the notes. Okay. And there's a Taylor's theorem problem which you should all get full credit on, because it's just, I don't remember what
Example.
Yeah. On 1C, yes. Yeah. Okay. So that's about all I wanted to say. I will not do the calculation today. I will do the calculations next time. I will do some easy problems. And the points that I'm trying to make is that you can reduce, I gave you baby problems, basically. Baby problems of the constraint type, where if you can always reduce it to a calculus 1 problem. A constraint problem can be reduced to a free problem, and then you can solve it either by the methods of this class or calculus. The 1A is a problem which you can, no, not 1A, 2A is a problem which you can reduce to basic calculus. I think 3A maybe also is like that. Okay, so that's the setup. Okay, and after you finish, I will take navy blue beard and purple beard's solutions and take some mixture of them and put them on for the next set of students. For the next generation of students.
You're gonna be the lucky one.
Oh, it's not much lucky for. What kind of beard? What does that mean?
That's a shade of blue.
How do you spell it?
SMARAGDEINE.
S-M-A-R.
SMARAGDEINE.
I have not seen this color, and if I have, I didn't know that that's the name. Okay, so I will have to look up the color. Okay, but okay, the people on the
Emerald green.
Well,
Yeah.
no, type in emerald green, then look at the next, oh, is it Lily emerald green?
the people who are here virtually, are there any questions? Do you have any questions?
Well, you just see the fancy.
Just a moment, just a moment. Yeah. Yeah. Any questions? People who are, I'm asking the virtual people. No? Okay, so then we will actually end the class now, and we will continue on Thursday. And meeting for all.
Yes.